Solid Edge is even more tightly integrated with other downstream processes and now has the ability to transfer assembly kinematic information to applications such as NX or Process Simulate in order to perform further dynamic studies or operations. In this example, we save time and minimize errors by transferring the motion kinematics of this robot arm from Solid Edge to Process Simulate. Starting in the Solid Edge motion environment, we'll make sure the kinematics are properly defined by selecting the parts, then choosing which ones are moving or fixed. This creates the 7 needed joints to replicate the 7-axis Panda robot. Once this is done, the motion of the robot can be verified by running the basic simulation. Now, the Solid Edge model can be exported complete with all the appropriate kinematic information and subsequently opened in Process Simulate. Once in Process Simulate, we can see that by using the Joint Jog option, all the relevant kinematics are present without having to do any additional manual setup work. The kinematic information of all the joints can be viewed by setting the modeling scope and using the kinematic editor. Here, kinematic relations are used to define the robot and simulate the reach movement. We can see that all the joints are correctly connected with each other in the sequence that was defined in Solid Edge. The movement can then be defined from the tool center point frame using inverse kinematic movements that are calculated automatically. Finally, we can simulate the action of the robot and see the exact movement needed to mix our drink of choice. Solid Edge increases productivity by providing even closer interoperability and integration with other solutions in the accelerator portfolio from Siemens, such as Process Simulate and NXMCD Concept Designer.